Hey guys, welcome back to the Mini Machine Shop. I'm Dave. Bunch of stuff going on here in the shop, playing with soft jaws and a whole bunch of stuff. So, first comment, last video I showed die-chem on this part, which was put in the lathe, and as it was spinning, just put the brush on it and coated it. This is layout fluid. It's supposed to scratch off. In the last video, I'm claiming it's indestructible paint. I couldn't get it to scratch off. Let me try again. The drill bit, it's sharper than I'll get it. Yeah, now it scratches off. Alright, so not indestructible paint, but pretty cool stuff anyway. Comes in an aerosol can, I realized, for even coverage if you want to just spray it on stuff. So, alright, that covers that. Started making the adapter here for the Tailstock, and came out pretty good so far. So I'm going to show making this guy, some of the machining and boring. Hey, get on there, it fits really good. And that fit came out by accident because I was boring this, and then I finally said, okay, how close am I? Like, oops, I'm right on it. So that was lucky. So I'm going to show making this guy, some boring going on and milling. Going to show a fancy do-it-yourself electric touch sensor that I used in the making of this. And also in the boring head, of course, I'm an engineer, and the thing gets really out of balance, of course, when you start running the cutter way out. So I started diving in and beating to death balancing weights and how this thing works. So show some of that. Some people were asking about the CNC conversion on the mini lathe. So I'll show some footage here on what I did to do the CNC and what's driving it. Ordered a new shop toy that I'm not going to talk about, that I can't wait to get, so hopefully it'll be here within a few weeks. And take you guys inside the house, show you something that I'm going to be fixing here and why. Alright, here's the back of my Pioneer Elite Pro, which started failing on me, just shutting down, and we did buy another TV set, a Samsung, but the picture just is not the same as a plasma. The picture on a plasma is just gorgeous. But I was kind of impressed with the workmanship that they did here. I mean, you can see all the vertical drivers, horizontal drivers, power supply for the horizontal, here's power supply for the vertical section. And I was also impressed, you can see all the fans on the top to keep it cool. This is how it was when I opened it, and this has been in service for about 15 years, and there's very, very little dust in here with all these fans running. I've never blown it out. But doing probing already, it looks like something's shutting down in the video section, and I suspect it's a power supply because all the other supplies are staying online and all the other signals are good. So I'm thinking that there's a voltage regulator down here. So when I get the time, I'm going to fire it back up again, wait for it to fail, and then go in and start probing around in the video section and see what's failing in there and what I can do to replace it. They discontinued, Pioneer discontinued making all their TVs quite a few years ago, but I do see a lot of these boards are on eBay. There are people that are repairing them, so if something gets real complicated, like I have to pull a large surface mount, I'm not equipped for that, so I'll send the board off to these guys and have them replace a specific chip. But that's my project, just wanted you guys to see it. So let's get on with the rest of the videos. Alright, I know I showed boring in one of the other videos, but I'm making the piece that goes on the tailstock, which is going to couple to a caliper, so I'm going to make a DRO for the tailstock, and I'm boring this out. And this is like, wow, I can't believe what this hole looks like. So, I take it around, loosen it up, take 15,000th cut, loose, and I'll go in 15. thousandths. Tighten it up. Put the shield in the way. Take it down. I'm just hand feeding this thing. I get where it's real bit. Gorgeous hole. Jeez, I wish there was eight. That's a little bit stiff. Need pliers to get that off without cutting myself up. Wish there was a way I could get cutting fluid in there while it's spinning. Come on, off. Yeah, that's probably more than 15 thousandths. But this is nice. So just want to show a little bit of using the boring tool. Alright, just show you guys sometimes when I want to do a perfect bevel job. I had put the parallels underneath, clamped this guy down now in between two plastic parallels that I had made. So now this part is completely insulated from the machine, isolated. So I crank it in here and you should be able to hear the beep when I connect. Turn it a little bit here. There it is. That is absolutely perfect. Get this guy off, back it out, zero the DRO, and I want to come in 5 thousandths. 1, 2, 3, 4, 5. No, there's 5. And bevel it. There it is. 3 sides. 1, 2, 3. All beveled perfectly just to a 5 thousandths. It looks nice. Yeah, I was just kind of messing around here with the boring head to figure out if there's a way of balancing it. So I weighed it and it's exactly 9 ounces. But looking at it, I'm going, wait a minute, I was putting the boring bar in here. There's a huge piece of metal missing right here. That can really throw it out of balance. So I got to machine something that'll go in there, because this is right now. This is alright. That's open. That's how do you figure that one out? I guess I got to put a piece of metal in here to take care of that weight. Put a piece of metal all the way down in here, because that's solid. Yeah, it's got to go all the way down. It goes way down. That'll take care of that weight. Because how much is missing here? This is missing a piece of metal right to the edge. I'm wondering if both of it makes it the same. So it's missing a slug of metal, 760. This is missing, oh, way more than that. Oh, jeez, 1.2 inches. So make a slug that fills this hole. Yeah, I might as well just fill both holes. I'd love to make another one of these too, where this is just a little bit further off center. Then I wouldn't have to travel out as far. Alright, well, off to the lathe. Let's start making a part. Yeah, alright, one video I'm talking about tolerances on the cutters. This is why I use the gauge pins. This is .499 and it just fits in this hole. 0.5 does not go in here. And you're supposed to be using 1/2 inch. This hole that I was using is sloppier. It moves quite a bit. This hole is real tight going down in there. That is definitely 0.499. You're not getting half in here. Oh, you can even hear it pop. This guy, yeah, this has got slop. So two holes that you can't put a 1/2 inch boring tool in, unless you do something else like bore this out, drill it out. Well, it looks like it's been precision machined. The sidewalls looks like it's been ground. So they blew this. Alright, back up for a minute here. Even though the boring head for the final cut, finishing cut, was way out here, the finish came out pretty good. I don't know if you can really see. Hold it around a bit there. So the inside's nice. It's smooth. Even for a boring bar, you can still see the little lines in there, but yeah, I was hand feeding that thing. So on the balance, like I said, I was looking at all the missing metal. There's more metal missing on this side than this side. This should be way out of balance right now. So I put it in a mill and spun it up, and it's in perfect balance. So I kept looking at it, wondering how, what, why. And it's definitely, there's more metal missing here. This hole goes really deep down in here. That far, almost to the bottom. Whereas this is not that much. So I took it apart and discovered this part, there's a big trough cut to the middle in here. So that's the missing metal here, which compensates for the extra missing metal here. So that's why it's in balance. So I figured, okay, let me just make, and here's 2 slugs that I made. I'll put one in each side, and I tighten them down so they were just flush, put it in the mill, spun it up, perfect balance. Threw this thing off a little bit and pulled this guy out and clamped it, stayed in balance. But the issue is when I start going out that way, the cutter is also the weight of it's going to happen. I took this guy pretty far out. I'll show you how far I really went. Because this is almost as far as I had to go to make that part. Somewhere's around there. And with this weight in there and this weight flush, yeah, it was vibrating like crazy. So I pulled this all the way out until the set screw was just holding it, and it did improve the vibration. It reduced it. So I need to make another one of these guys longer, probably twice as long. Because I'm not sure why that didn't do it. Because I'm looking at this going, this part weighs 9 ounces exactly, and it's almost 2 inches. And if you divide 9 ounces by 2 inches, you're going to wind up with, you need like 0.045 ounces for every tenth that you're going out. And this was, how much was this weigh? Well, 0 out, thank you. That guy is 0.6 ounces. So this should have been enough of weight without having to make a longer one to balance it out. So probably something wrong in my math. But yeah, another interesting thing is this finish. I was trying to get nice finishes like this on the end with the diamond wheel and a bunch of different things. Just didn't work out. All I did was put this on the belt sander, and it is smooth, and it rides real smooth on the granite surface. So that's a kick. Can you feel? You can feel a little bit. If I went to a finer grain, that would work. But yeah, the steel was pitted. I came down. What is it? 497. Yeah, 497. This one's off or not? 497. So I buffed them up. I had to hold them. It was crazy. So I pulled out my Toolmaker's clamp that I had made a long time ago. And I realized, I haven't said anything in the video, that I blew it. This is not how you make it. I saw somebody make one like this. So I'm not sure where, and that's why I duplicated it where both slide. It's not supposed to. This is supposed to be threaded, That's open. This is supposed to be threaded, not free, and this isn't even supposed to have a hole in it. Because right now, if you clamp on something, it's going to do that number. And just, it didn't hold this. So what I wound up doing to get it to work in the buffer. That's kind of cool. I put one on this end, put one on this end. Now I can buff both of them at the same time. And this clamps down hard too. I don't know why it was so difficult to get it loose, but they're in there. Not if I clamp on it. But I had to crank to get this thing loose. And I've got a nylon washer in there. Yeah, both sides is nylon washers. But I need another project is to make one of these things correctly. And then I saw in the video too, they do a notch in here and they put a little piece of bent metal in there, so if this doesn't move around like this, it stays with it. So when you open it, it's pulling it and closing it. So that's been fun. Waiting for the caliper to come from Amazon. Then I can finish up this end, put a set screw in here so that it'll clamp down on the tailstock. And I guess I'll oil this guy up and store him back away and make a bigger pin and just put it all in the box. So that's about even. Yeah, I was thinking too, boy, these better stay put, because if they fly out, man, these are going to be like bullets coming out. So I'm going to have a shield always, a plastic shield always in front of this guy when I'm doing the cutting. Okay guys, hope you enjoyed. Yeah, I had promised that I was going to show the mini lathe and the CNC stuff that I did. Simple plate, just machined it out. This motor is way oversized. I didn't need anything this big at all, but I thought I was going to have problems. And simple couplings that, oh yeah, I took the lead screw out, drilled it, tapped it. There's a little adapter that screws into the lead screw, and then this guy just clamps on it. And this guy is engaged all the time, and when I do the power feed, it turns the motor without any problem. So the other guy back here, another simple thing, same thing, lead screw taken out, drilled and tapped. Let me bring this back more. This one though, you can see the motor's not turning because I do a lot by hand. So when I want to do CNC work, there's the adapter, and go straight down. So it's just screwed in there to the lead screw and then clamped. Junk all over the place all the time. And these adapter flex fittings you can get all over the place. I've seen them, you know, oh, I can't remember right off the bat, but I think they're even on Amazon. So simple motor mount. All the wiring just kind of goes up under here, and then the electronics is over here. And all the stuff, you gotta go down. Yeah, I think you can see a lot of it. There's the drivers, two of them, and I have room for a third one. Power supply off of Amazon to run it. And another power supply over here with just a PC fan stuck on it. And there's the interface board that goes between the PC. Now the thing is, back when I did this originally, and then yeah, the PC is right here that drives it, and usually I have to put it up on the bench. Now what I was saying is, where's the cable? There's the cable back in the dark, the parallel port. Back when I did this, Mach 3 was parallel port only, and it's really hard today to find a PC that has a parallel port on it. And then I tried to buy a board, and I bought one off Amazon, and it didn't work. So I got a PC that's got a parallel port on it, and I can talk to Mach 3, and so there's the CNC, and I just do G-code right now. I did download some trial of CAD CAM programs, Dolphin CAD CAM, and there were some other ones, but just didn't really get into it that much. I did make a few parts using the CNC, and the finishes came out gorgeous on it because it's now speed controlled, really precise, so it was great. But nowadays, if you go, I bought all the electronics and stepper drivers from CNC for PC. If you go there today, you can get a USB interface, but you have to get Mach 4 which is still kind of in beta. I think they're starting to sell it to amateurs. They're not selling the professional one yet. But go and find Mach 4. I don't even think they have a trial, but that's the way to go, because I'd love to just, use my tablet that I've got over here. The tablet that I showed the HP guy, because that's got a USB port on it, and I'd love to just stand there and run the whole thing. So whenever Mach 4 is released and I go and buy a USB interface, I'm going to be up and running. So that's kind of it for CNC on the mini mill, or lathe. I always do that. Alright, enjoy.